Hey guys, this is Aaron Nunley with Nunley Math. Thank you so much for joining us here again today. I had a quick topic that I wanted to talk about. Won't take us real long today, and I am going to use the cross-section flyer tool from Shodor.org to help you understand this. A very common question that we tend to run into when dealing with cross sections of 3D figures is what happens when you slice a three-dimensional figure horizontally or parallel to its base. In other words, if I had in this example, pentagonal prism, what would happen if this were made out of clay or something like that, and I were to just slice it right across horizontal or parallel to the base? Or maybe you could think of it as being wood, and if I were to take a saw and cut across, what would the interior shape look like? Now, I talked to you in a previous video about how this tool can help us see what cross sections look like. So I want to speak specifically today about what happens when you slice this horizontally, and then what happens when you slice it vertically. I want you to notice a couple quick things here real quick. If I have a pentagonal prism and I slice it across horizontally, it doesn't matter where I slice it from, if it's near the top or in the middle or near the bottom. I want you to notice something. The shape of the cross section always matches the shape of the bases. Let me slide it all the way to the top. You can see it matches at the top, and you can see it matches at the bottom. It's always going to match. In fact, it doesn't even matter what the shape of the base is. I could change this into a square base. Notice that the cross section always matches. I can turn it into a triangular base. Notice the cross section always matches. Or I could turn it into something weird like a nonagonal. Is that nonagonal? Actually, I think that's 7 sides, or I don't know, however many sides that is. Notice that when I move the slice up and down, it always matches. You can actually also see that over here on the right, this figure is not changing at all as I move this up and down, because not only is the cross section going to be the same shape as the base, but it's always going to be the same size as the base as well. This is always going to create congruent figures. Notice if I turn it into a cylinder, the exact same thing happens. Since my bases are circles, my cross section is always going to be a circle as well. Notice again, this is not changing because the cross section is always going to remain the exact same size. That's only with prisms and cylinders. If I switch over to a pyramid and I do the exact same thing, notice if I have a pentagonal pyramid and I slice higher or lower, the shape stays the same, but the size keeps changing. The size keeps changing. The horizontal cross sections of a pyramid are always going to be similar to the base. In other words, they're going to be the same shape, this pentagon, but they're going to be different sizes. And that's going to be the same regardless of what the original shape was. Notice that these are all squares, but they are similar squares. These are all, let's go, what am I at, hexagonal? These are all hexagons, but they're changing size. If I switch this to a cone, the exact same thing happens. So that's the quick lesson for today. Horizontal slices of prisms and cylinders always create slices or cross sections that are congruent to the base. And if I go over to a cylinder, same thing. If I switch to pyramids, I always get things that are similar to the base. Prisms and cones, or prisms and cylinders, are going to be congruent. Pyramids and cones are going to be similar to the base when we do horizontal cross sections. In just a minute, I'm going to go ahead and post another video that's going to do what happens if I slice them vertically through the apex. So make sure you watch that as well. Thanks again for watching. You guys take care of yourselves. Bye-bye.